Good morning, all. I'm here to present the topic optimizing multi-tenant database architecture for efficient SaaS delivery. The contents of my presentations are introduction, literature survey, proposed approach, results, and conclusion. To introduce what a multi-tenant database is, multi-tenant database are the foundations of the SaaS delivery model of the cloud. So when we want to deliver software as a service, we at the back end, we need a multi-tenant database design. The multi-tenant database designs helps us to serve all the tenants using single shared resource. And this is the idea on which, in terms of cost and expenses, the cloud gains advantage over the other way or over the other way of delivering the services. So every cloud-based SaaS delivery model heavily depends on the architecture of multi-tenant database. The more efficient the multi-tenant database design is in terms of storage and in terms of query performance, the better would be the cloud delivery services. In this paper, what we have tried to do, we have designed a multi-tenant database that is query efficient and that is space saving also. So we'll talk about it later. So taking it further, to talk about the literature survey that we have done. So we have seen the literature in the research domain where people have used pivot tables, chunk folding approach, universal table approach, extension table approach, and also a multi-tenant database which has an improved extension table approach. The state of art being this multi-tenant database extension table approach, table design, which has been used for a long time and is also in use currently. So if we see this database schema or design, we will see that there is a primary table, and then there is an extension table, and then there is a metadata table. So the primary table holds the key informations or the primary informations of all the records, and further, if a record is stretched to multiple attributes, those attributes are handled in the extension table. The inference of what is there in the extension table, that is the label of the data, can be found in the metadata table. So this is the state-of-art database design, which is being used and which is predominantly used in the many multi-tenant database designs. Now, in the proposed approach, what we have suggested is that instead of using this extension table approach, in which there is always a vertical growth, we propose that we can combine multiple attributes and store it in the form of a JSON or XML file. So the advantage that we will get in the first place here is we can combine multiple attributes in a XML file or a JSON file, and we can store it in one attribute space itself. So in this way, we would be saving a lot of space, and we'll also see how the query performs when we put the number of attributes in the common field. Also, we intend to go for a multi-tenant database design because we know that the requirements of tenants can differ. We can never design a single table which can accommodate all the requirements of the varied tenants. So the requirements of different tenants can be different, but there can be certain key attributes that are common. So those key attributes which are common across all the tenants can be put in one place. And for the differing attributes, we can use JSON or XML-based attribute where we have the XML file or the JSON file containing multiple varying attributes. Now, the design is very simple and very intuitive. Let us look at how the performance of this design happens. So when we did the query performance, specifically for queries like insertion, updation, deletion, selection, and we applied this approach to different approaches. Like first, we used this approach using XML and JSON, and then we used also this approach with caching, the same XML and JSON approach. And we compared this to with the extension table approach. Now we can see that the query performance, that is the time taken to execute a particular query per unit time, as in the case of insertion, is always better than the state-of-art approach. For updation also it is better than the state-of-art approach, and for deletion also it is quite better than the state-of-art approach. But when we see for selection, we see that in selection, the performance is bit low in the proposed approach using XML JSON, and also when we are using caching, the approach improves. It tends to match the state-of-art approach, but yet it is still a bit less because the parsing of XML file is involved. But when the parse XML file is used with caching, then we get little more advantage. Further, when we see that as we add more number of varied attributes, so how the query performance varies as in case of proposed approach and in case of extension table approach. As we can see in the extension table approach, as we increase the number of attributes, the query performance is degrading. Whereas in the proposed approach, the performance is decreasing, but not that exponentially. It is almost linear, and it is only gradually decreasing. Further, if we look at the storage requirements, here we gain in a very heavy way, where we see that, as in the case of proposed approach, the storage requirement again does not exponentially increase with the increase in number of added attributes, whereas in the case of extension table approach, the storage requirements increase radically. So when we adjust the query performance, when we are performing concurrent queries on the XML table approach or the proposed approach, we find that in case of the proposed approach, also it matches the extension table or the state-of-art table approach in case of concurrent queries. To conclude, in the proposed system, the multi-tenant database is the backend that we have suggested, we have used, and we have used XML or JSON file to store the varying attributes, which reduces the storage needs and increases the transactional efficiencies. The experiments performed on the multi-tenant database design and the state-of-art approach shows that how the proposed approach is efficient in terms of query execution, in terms of saving space, in terms of query performance in concurrent cases, concurrent query executions. So we conclude that the suggested method consistently outperforms the state-of-art design of multi-tenant database, and the database design can be further used in all SaaS delivery models to provide better services. Thank you for your patient listening. Thanks so much.